Good day to everyone. Welcome back to Saji's physics classes. Today, ninth lesson of moving charges and magnetism, chapter 4, grade 12. In the previous class, we discussed Ampere's circuited law and the applications. Today, we will discuss a very important topic. We will learn the equation for the force between two parallel conductors carrying currents. So you consider two parallel conductors. They carry currents. There is magnetic field between each conductor. So this magnetic field will interact. So the conductors will either repel away or attract. We are going to find out when they repel each other and when they attract each other, and we derive the equation for force per unit length between the conductors. Okay, ready? So today's topic is force between two parallel conductors carrying current. Force between two parallel conductors carrying current. You already know the equation for the force acting on a current placed in a uniform magnetic field. Force between two parallel conductors carrying currents. When a conductor carrying current is placed in a magnetic field, it will experience a force. You know the equation for force we have derived in this first or second lesson. Okay, what is the equation? Force on a conductor placed in a current in a magnetic field, uniform magnetic field, is F is equal to IL bar cross B. The direction of this current is given by Fleming's left-hand rule. We have to use this equation. Okay. Now I am drawing two conductors. See, this is a conductor AB. AB. It carries a current I1 in the upward direction. So current is along positive Y direction. Now you know around any current carrying conductor, there is a magnetic field. And magnetic field line I am drawing. I am drawing a magnetic field line. And you know how to find out the direction of magnetic field, right hand thumb rule. So at this point, say this point is P, magnetic field, this point is at a distance R. The magnetic field field will be directed into the plane of the paper. That is, I write as B1. This is by right hand thumb rule. Current upwards, magnetic field lines in the way in which a finger scale. Okay, use right hand thumb rule. So magnetic field is B1. That is directed into the plane of the paper. And you know the equation for B1. We derived application of Ampere's circuited law. The magnetic field near a straight conductor, mu0 I1 by 2 pi R. R is the distance. Okay. Now I place the conductor CD in this magnetic field. I am placing a conductor CD parallel to this in this magnetic field. So this is conductor CD. Okay. That is parallel to the conductor AB. And conductor CD carries a current I2. Say both the current in the same direction, CD. Current say in the I2, upward only, along positive Y direction, J direction. Okay. And you know, this also has a magnetic field. That magnetic field line I am drawing, this one. For this magnetic field, here will be into the plane of the paper. You see, this conductor AB is in the magnetic field of conductor CD. See, at this point, magnetic field is out of the plane of the paper. This is B2. So conductor AB is in the magnetic field of conductor CD. What is the magnetic field of conductor CD? V2 equals mu0 I2 by 2 pi r. Since conductor AB is, you consider CD first. Since conductor CD is in the magnetic field of conductor AB, CD will experience a force. That force is given by the above equation, IL cross B. So force on CD I am writing is equal to I, current on CD is I2 L cross B. But this B is B1. CD is in the magnetic field of AB. B1 is the field due to AB. Now I2 into L into, you know, current direction is positive Y direction. So I am writing J hat. Cross this B1. B1 is into the paper, plane of the paper. It is minus K direction. Minus K hat into B1. Okay. So we can write I2 L B minus J cross K. But you know, J cross K is I only. So what will be the force? FCD equals I2 L, this magnetic field is B1 into minus I hat. So this force is directed along negative direction. So the force of the conductors CD is along negative X direction. So I draw the direction of current. Okay. See, the direction of force. This is the direction of force, FCD. It is along the negative X-axis. In the same way, you can find out the force on the conductor AB, and AB is in the magnetic field of CD. Okay. If I put the value of B1 here, what will be FCD? B1, you know, mu0 I1 by 2 pi r. I2 L into minus I hat. This is FCD. Now, let us find the force on AB. See, AB is in the magnetic field of B2. So what is the force on AB? Current on AB is I1, I1L. It is along I1L cross. It is the magnetic field is B1. I1L, current is along positive Y direction. So J hat cross, magnetic field is here AB is in the magnetic field B2. So it is I1L cross B2. So this is B2. B2 into, here it is in the K direction. B2 is in the K direction. So conductor AB is in the magnetic field of B2. B2 is, see the diagram, it is out of the plane of the paper, positive is a direction. You know that we have to apply Fleming's left hand. Okay. So we can write I1, B2, L, J cross K is I hat. So this force will be along positive X direction. Okay. So I will draw it into the diagram. So conductor AB will experience a force along the positive X direction. This force is FAB. This FAB is due to the magnetic field of B2, right? CD. See, these two forces, FAB and FCD, are opposite. Okay. CD attract. See, that means these forces are, conductors are moving towards each other. See, FCD is towards left. So FCD, CD will move towards the left only, and AB will move towards the right. That means these conductors attract each other. So when two conductors carrying currents in the same direction attract each other, so we can write FAB as B2 you can write as mu 0 I2 by 2 pi r I1 L into I hat. Okay. When the two conductors carrying currents in the same direction, what they will do? Attract. We can say parallel currents attract each other. Parallel currents attract each other. Parallel currents attract each other. And see the equation FAB and FCD, their magnitude is same, direction is different. So what is the force between two parallel conductors? Therefore, force between two parallel conductors F is equal to mu 0 I1 I2 by 2 pi r into L. This is the magnitude of the force between the two parallel conductors. You can find out the force per unit length. That is F by L. Force per unit length. F by L equals mu 0 I1 I2 by 2 pi r. Okay, so remember, parallel currents attract each other. Parallel currents attract each other. Now, if the currents are in opposite direction, what will happen? The currents will be repelling each other. Direction of force will be reversed. Okay, so I can that I just diagrammatically I am showing. See, this is conductor AB. This is conductor CD. Conductor carries current I1. So B1, conductor CD is in this magnetic field. So B1 will be in this direction, into the plane of the paper. Okay, suppose CD carries current downward. So what will be the direction of the force? You know, FCD equals IL cross B1 here. Here current is I2. So I2L Here current is along negative J direction, minus J. V1 is along negative. V1 is also along negative Z direction. So minus K hat. So I2L V1 J cross K. That means force will be along positive Z direction. I hat. J cross K is I hat. So force is in this direction. Force CD, positive X direction. Similarly, conductor B1 is in the magnetic field of the second conductor B2. But B2, you know, B2 will be in what direction? Apply left hand rule, right hand thumb rule. Magnetic field will be in what direction? For B1, magnetic field B2. B2 will be current is downward. So it will be into the plane of the paper. So here also magnetic field will be into the plane of the paper, B2. Okay. Now you can find out the force on AB, FAB. Magnetic field is B2. So current is I1, I1L cross B2. I1L, here current is in what direction? Plus J direction. Cross B2. B2 is along negative direction only, minus K B2. Minus K B1. See, AB is in the magnetic field of B1 only. So this is not B2, this is B2. This is B1. This magnetic field is B1. AB is in the magnetic field of B2. Okay, B2 only, correctly, B2. B2. Okay. So what will be the equation? B2 I1 L into J cross K minus. But you know J cross K is I only. So it will be minus I hat. So FAB will be minus I hat. P2 I1 L I hat minus. So force on AB will be in what direction? It will be along negative X direction. See, AB is moving away from CD. CD is moving away from AB. That means they repel each other. So anti-parallel currents repel each other. Always remember, parallel currents attract each other. Anti-parallel current repel each other. Magnitude of the forces will be the same. Okay. So force between two parallel conductors, magnitude is given by F is equal to mu 0 I1 I2 by 2 pi r into L. Okay. Using this equation, we can define Ampere. Definition of Ampere. Definition of Ampere. Force between two parallel conductors attract if the currents are in same direction. If they are in opposite direction, they repel. The equation for force between them is mu 0 I1 I2 by 2 pi r into L. Force per unit length is F by L equals mu 0 I1 I2 by 2 pi R. If I1 equals 1 ampere, I2 also 1 ampere. If I1 equals 1 ampere, I2 equals 1 ampere, R equals 1 meter, then what will be the force per unit length? Mu 0 into 1 by 2 pi into 1. Mu 0 is 4 pi into 10 raised to minus 7 divided by 2 pi. So you are getting 2 into 10 raised to minus 7 Newton per meter. Now we can define ampere. I am going to define, pay attention, 1 ampere is that current which when flowing through two straight parallel conductors of infinite length separated by 1 meter and placed in vacuum produces a force of 2 into 10 raised to minus 7 Newton per length. Okay, so what is the definition of ampere? 1 ampere is that current which when flowing through two parallel conductors of infinite length separated by a distance of 1 meter and placed in vacuum produces a force of 2 into 10 raised to minus 7 Newton per meter. This is a definition of ampere. So this is an important derivation. Short answer also, it will be asked, draw the magnetic field pattern. All these you should remember. So we can define ampere. Once again, how ampere is defined? 1 ampere is that current which when flowing through two straight parallel conductors of infinite length separated by a distance of 1 meter placed in vacuum produces a force of 2 into 10 raised to minus 7 Newton per meter. Okay, everyone. Thank you for watching. Okay, watch the video again. Make your concepts clear. Score good marks, 100 marks. Okay, today I end the class. Meet again in the next class. Goodbye.